Hi, my name's Gabriel Weaver. I'm a graduate student at Dartmouth College, and today I'm really excited to talk to you about some tools that my colleagues and I have been developing to help manage the smart grid's data avalanche. Even at a very high level, the smart grid is reasonably complex, as you can see here. It consists of 7 different domains, and already, even today, it's already very large. If we even just look at the customer side of things, in 2010 there were 300 million people in the United States and about 160 million residences. Today, as of 2012, there's about 18 million smart meters deployed. So there's going to be a lot more smart meters deployed over the next few years. Furthermore, there's 250 million registered cars as of 2010. And as those cars become more and more electric, the smart grid's only going to grow in size. If we look at just one IOU that was studied at Idaho National Labs in 2009, we can see a great number of devices. One IOU was in charge of 200 substations and 1 million customers, residential customers. And if you look at the devices in this diagram, you can imagine how many and how large the smart grid's going to become. And as a result, all these different devices speak many different protocols, have all sorts of configuration languages, and have a bunch of different log formats. And so we have an avalanche of disparate data. And failure to manage this data has real consequences. In the NIST-IR report, you can see they talked about increasing exposure to potential attackers and unintentional errors. Furthermore, they documented these potential vulnerabilities in terms of top-down vulnerability classes, bottom-up threats, and the NERC SIP provisions also address these concerns. Our research really addresses barriers to assessing and monitoring risk in the smart grid. In the 2011 roadmap, the roadmap says, in 0 to 3 years, we want common terms and measures specific to each energy subsector so that we can baseline security posture and operational settings. And there's a few barriers there. One is that there's disparate data from a variety of sources and levels of granularity. And in the NIST Smart Grid Program Overview in 2012, they call for new measurement methods to be able to make sense of the smart grid. And our tools notice that a lot of the newer protocols and data formats for the smart grid have hierarchical object models. And we can leverage that because our tools operate on context-free languages, which by definition are sets of strings with arbitrarily deep hierarchies. And these are the kinds of arbitrarily deep hierarchies that we see in formats in the smart grid. And we really want to give administrators and auditors practical capabilities to, and at the same time, address these roadmap barriers. Barrier number 1, disparate data. We already saw that there's quite a wide range of data that we need to be able to handle. Barrier number 2, multiple levels of data granularity. How do we handle that? Well, our XUTools encode hierarchical structure as parse trees, and so we can actually process those parse trees, and we can process text at multiple levels of abstraction. And then barrier number 3, we need new measurement methods. Our XUTools use tree and string edit distance metrics so that we can actually measure change over time within real-world data. And we process data at multiple levels of granularity to pinpoint complex network security primitives. This is the first capability that I want to talk to you about today. So the data set that we use is artificial but realistic. It actually comes from real utilities, and we have 5 firewalls here. Their IP addresses have been anonymized and some hosts have been removed. So if we look at this data set, we get a high-level view, but we may want to be able to pinpoint security primitives. Why would we even want to be able to do this? We want to be able to inventory security primitives, for example, so that we can catalog the roles, that is, groups of users, protocols, and devices that are used in access control. Network configuration management literature says that the more roles firewalls have makes them harder to manage, more prone to misconfiguration, and misconfigurations lead to outages. That's documented. Also, we want to be able to quickly identify large security primitives. We don't want to just know how many roles there are. We want to know how large are those roles on the firewalls. So we can identify important parts of the network that are harder to maintain. And this addresses a whole bunch of different vulnerabilities and regulations. If we can do this efficiently and quickly, we can reduce audit costs because we can save people time. We also get to the management and usability of roles by being able to actually inventory them and measure their size. And finally, we start to address baseline configuration development. So what are we going to do today? How are we going to be able to pinpoint these network security primitives? It's a 4-step process. I'm going to show you what we're actually going to show you in a little while. First, we're going to load network configurations into the XUTools visualizer. And we're going to do this using the diagram you see in the command column. What is going to occur is we're basically going to open up a directory full of configuration files, and we're going to create a set that represents that directory. For every single file in that directory, we create an element in that set, and the element contains the contents of the file and is labeled with the file name. Now we really want to be able to extract the roles that are defined within those files, and this is where we use XUgrep. Our XUgrep basically has a definition of what a role looks like. In Cisco IOS, it's an object group. And so we're going to express the query. We want all object groups in the context of configuration files as a parse tree. We're going to walk that parse tree in a post-order traversal. And as we go, we're going to change the elements in the set that we give as input. So for example, when we get to the green node, the iOS object group, we're going to scan the input elements for all strings that are in the language of the object group production. And we're going to output that to a new set of elements. Now that new set of elements is going to have a string that corresponds to the object group defined, as well as the name of that object group within the context of the router name. Finally, we want to be able to compute the size of each of the roles. And to do that, we're going to use our XUWC tool. Here we calculate size in terms of the number of lines that are within that object group. What we do is we create a query, we create a parse tree corresponding to that query, and we basically just are able to count the number of lines per object group. Once that's done, we can view our result using a set view, and you're going to see that right now. So the first thing that I want to be able to do is load the configurations into my XUTools visualizer. So we're going to click load, and we're going to end up with a set of configurations that we can view right here. As you can see, this mirrors what we saw in the NetAPT view. We see 5 firewalls. Next, I want to be able to grep out the roles that are in each of those configurations. So what I do is I'm going to give it the set of configuration files. I'm going to extract all occurrences of that role structure that we talked about. Those are object groups in Cisco IOS. And I'm going to put it into a role set. I click XUgrep, and it's computing right now. And I'm going to get a set of roles that I can then drag and actually see right away some useful information. For example, the internet firewall only defines 2 roles, whereas these other firewalls define many more roles. Finally, I want to see how large these different roles are. So I give XUWC the set of roles. I say I want to measure size in terms of lines, and I'm going to output results in terms of in a role size set. I click XUWC, I get the role size sets, and I can see right away that in this primary EMS firewall, business lines, the role that's called business lines, is 14 lines long, whereas something like EMS clock is only 3 lines long. And so what we can see is we have the ability to pinpoint useful information very quickly, very efficiently. Another capability that we want to be able to address is we want to measure security primitives and how they change over time. Change logs are time-consuming to write, they're costly, they can be manual and error-prone. Furthermore, the relevance of logs might change over time, and they're written at many different levels of abstraction. So if we can generate change logs, that's a real benefit. Furthermore, we want to be able to measure how security primitives have changed over time. For example, an object group defines roles, and if I can extract roles and they have identifiers, I can actually measure how those roles change over time, start to quantify things like role drift. And finally, I can see how frequently security primitives change within a network. This addresses a whole bunch of different vulnerabilities and regulations, and our XUdiff can really deliver these capabilities because we measure change with algorithms that compute string and edit distance metrics. So to conclude, I guess I want to say thank you for your time and for listening. And our XUtools are defined to accommodate a whole bunch of different formats that we see in the smart grid. And here we list some possible future directions for our work. So thank you for your time and have a nice day.